Okay, so let's go ahead and get started. I'm recording this if you need to go back and watch it, or if you're at home, this is what we have as our extra study sheet for the test Thursday over chapter, 8.2 to 8.5 and 8.7, bless you. So the question on the test actually says, are these points collinear? Do you remember how we told, are they collinear or not?
If all the x's are different.
Well, that was telling whether if it was a function. If all the x's are different, that tells whether it's a function or not. If they're on the same line, won't they have the same slope if they're on the same line? They will have the same slope if they are collinear. So I'll write that down. How can I determine the slope from the table? Do you remember slope is the changes in y's over the change of x? That's the way we could write it. We got tons of ways to write slope. Rise over run. Change in y over change in x. Is there a way I can figure out the change in the y and the change in the x from the table? Is there a way to figure it out from the table? There is. Here we go. Let's do it together. I'll remind you, because that's what I was worried about, is that you might not remember. Adam?
What did you say the point was? Because
All right, so if I want to know if these points are all on the same line, if they have the same slope, they're going to be on the same line. So if you remember what we did, we said, okay, if slope is the change in y over the change of x, let's see what the change of y is, bless you. From 7 to 11, what did we do to get from 7 to 11? We added 4. Remember us doing this, guys? Y'all remember?
Yeah.
From 11 to 15, what did we do? Added 4. Okay, so far it's looking good for them to be on the same line, because at least the change in the y's is always 4 on those points, right? But I still got to check out the change in x's. I got to have the same numbers on each side, like I got to have all 4s on the y's for this to work. So let's go check out the x's, because they've all got to be the same too if this is going to work. If I go from 1 to 3, how much did I add to get from 1 to 3? So the change in x there is 2. How about to get from 3 to 5? 2. So the change in x there is also 2. So, hey, it was the same on both sides. Therefore, they are on the same line. We can actually tell what the slope is from this. If the change of x is 2, the change in y was 4, the y's go on the top, don't they? Remember that for the test, because that's what a lot of people will mess up on. They'll try to put x's on top or something. I'm not going to ask you for the slope on the test, but you could tell it's 4 over 2, so the slope of the line that these are all on is actually 2. Okay, so you can find the slope from a table as long as you have the same change on both sides. If you don't, you probably need to do something else.
So,
well, the question just says, are they collinear? Yeah, you always reduce fractions. Anytime in math you get a fraction, you're always going to want to reduce it, okay? But the answer to this question is, the question on the test is, are they collinear? Yes. And you don't have to tell me the reason, but I'm going to write it here just so you understand it, because they are all the points, they is referring to the points have the same slope. If they have the same slope, they're on the same line. Same slope. Okay? So I've actually shown what the slope is, even though you don't even have to tell me that on the test. But see how much information you can get from that table? Could you, if I give you 2 points on the test and ask you for the slope, could you just put them in a table and do it that way? Find the slope that way, as long as you remember to put the y's on top and the x's on bottom as far as the difference in them? You could actually find the slope that way. That's what a lot of people like to do because they don't like formulas. Okay. Okay, the next question asks you to find the x and the y intercepts, and here's an equation. Do you remember how we did that? There was an easy way to do it when it was in standard form. Does anybody remember? What now?
Subtract 3x.
Well, I mean, we could go put it in y equal mx plus b form, but that's a lot more work than we have to do. What's your idea?
You set y equal to 0 to find the x intercept.
Uh-huh. Okay, so to find the x-intercept, set y equal to 0. And then to find, I'm going to come down here and write the other one just so you kind of get this in your head. To find the y-intercept, set x equal to 0. We're always setting the opposite variable equal to 0 when we're finding intercepts. And remember, you're going to write them as a point. So let's practice writing them as a point now. Okay. Now, if I'm going to do this, first of all, I already know half of each coordinate point, don't I? Because to find the x-intercept, I'm setting y equals 0. So remember, the x goes first and then the y. I could go ahead and put my 0 in there because that's what I'm going to do to find that number that's missing that I want, right? If I set y equal to 0, I would have 3x plus 7 times 0 equal 21. Well, the good thing about this is anytime you multiply something by 0, it becomes 0. So I would have 3x plus 0 is 21. And 3x plus 0 is just 3x. What would you do to find your x? Divide by 3, right? What would your answer be? 21 over 3 is? 7. Okay, so we just need to put the 7 in the x spot. We just found it. Bam, that's done, right? We're going to do the same sort of thing on the bottom, except this time we're going to put x is 0. So before we get started, so you don't get confused, because I think that's what's happening sometimes with the intercepts. I noticed on the quiz we took over that. X is actually 0, so you're going to plug it in. Go ahead and write it in the point so you don't forget that you chose to set x equal to 0 so that you could find the y-intercept. Okay, so it's 3x is 0 plus 7y is 21. Well, 3 times 0 is just 0. 0 plus 7y is just 7y, right? So if I want to know what the y-intercept is, I just need to divide both sides by 7. I'm just solving that little equation that we get, and usually they're nice and simple. 21 over 7 would be 3. Okay, so here's the thing we got to remember about standard form. I'm just going to abbreviate over here. You need the x and the y terms on one side, and that means that your constant will be on the other side. Your plain old number will be on the other side. Because remember, the form is ax plus by equals c. You always want a positive x, and you always want no fractions. So if you get fractions, you kind of clear them out by multiplying through something that would clear out all your fractions. So let's see. Now there's two things you could do here. If you want x and y on the same side, one thing you could do would be subtract 6x from both sides, right? The other thing, though, there might be another way to do it, and a lot of people I've noticed that I've explained this to prefer this other way. And the way they prefer is to just, since you got to have a positive x, isn't the x positive where it is? You're going to have to do two steps no matter what you do. So here's one way a lot of people like to do it. They say, okay, I need a positive x, I already got a positive x. Why don't I leave the x's there, and I'm like, move the 5 to the other side. And then, since I need the y with the x, I'll just subtract the y from both sides. That's one way you could do this problem. It's not the only way, though. I'll do it another way in a minute. Here's another way I could have done that, because some of you aren't afraid of negatives, and that's fine. Is that the right problem? Oh, it's a plus. Okay, let's say I don't care about worrying about that positive x thing. Here's what some people do. The first way I showed you, if you don't like negative x's, that's one way to avoid it. I could, though, another way to do this would be just to go ahead and subtract the 6x from both sides, and I would have negative 6x plus y is 5, but I have a negative in front of the x term, so I need to multiply every single thing or divide every single thing by a negative 1. That would change the signs on everything. Negative 1 times negative 6x would give you a positive 6x. Negative 1 times positive y would give you a negative y, and I also have to do it on both sides, right? 5 times negative 1 would be negative 5. Don't we get the same answer if we do it that way? We come up with the same thing both times. It's just, if you're a little afraid of having to multiply or divide by a negative because you think it might make you mess up, you could just subtract the terms and, get your x term positive. If it's positive, leave it where it is, maybe. Here's our equation. F of x is equal to x plus 2. 4 and 5 are all you really need to worry about for the test from the section we did yesterday. And they tell us our domain is all real numbers. That means I can plug anything in that I want to. So they want to know what the range is. When you have a line, and almost anything, this is true, not everything, not the weird stuff you start getting at the end of Algebra 2, but for almost everything, if I plug in any x that I can think of, usually my range is also going to be all real numbers. If I want to plug in anything I can think of, that's how I would say that I can plug in all real numbers. So my range is usually going to be all real numbers. You could test this out a little bit if you wanted to. Let's make a little table and pick some x's and let's see where our y's fall. If I pick x is 100, just to remember, well, first of all, what can I do with this f of x if I don't want to look at it? Yeah, cross it out and put y. Okay, so y equal, if x is 100, I'm just going to add 2 to it. That would be y is 102. If you had a graphing calculator, you could type this in and you would see that if you graphed it, it's going to look something like this. And since it goes on and on forever up and on forever down, if I plug any x I want to in, that means I'm going to get any y you could think of, right?
So you plugged 100 in for x?
Yeah, okay, so that's telling me I got stuff over here, right? I'll just kind of scribble on the graph. What if I plugged in negative 100? What if x is negative 100? By the way, I could write that this way, couldn't I? Because when they put the number in the parentheses, they're just telling you what x to plug in is all they're doing. So that would be negative 100, and again, if you don't like it, cross it out and call it y. Negative 100 plus 2, wouldn't that be negative 98? So negative 100 would give me negative 98. Hey, that's way down here, isn't it? The bigger number I pick for x, the bigger number I'm going to get for y. The smaller number I pick for x, the smaller number I'm going to get for y. I'm going to hit just about anything I'm going to hit anything I can think of. So that's why my range here is going to be all real numbers. For lines, unless they're vertical or horizontal, your domain is usually all real numbers and your range is all real numbers. So if you just know this, you're going to be able to answer the test question because all I did was just give you a different little equation. It might be x plus 5 instead of x plus 2. All lines that fit y equal mx plus b have a domain of all real numbers and a range of all real numbers. So that's kind of an important thing to know. Okay, let's go over the last problem, and then we'll correct quiz questions, and then I'll let you guys maybe ask me in the order you need them. All right, number 5 says if f of x equals 6x minus 5, find, first of all, let's do one at a time. F of 3, what's that telling me to do? When they put the 3 in there, that means what? Yeah, it means x is 3. Plug in x equal 3. So that would be 6 times 3 minus 5. 18 minus 5, right, would give me 13. If you want a calculator, you can bring it. It doesn't need to be a graphing calculator. Anything that would, if you want to run numbers through the calculator, that would be fine. The next one they ask is f of negative 3, so that means plug in, here's my equation, I'm going to plug in x is negative 3. That would be negative 18 minus 5. When you add negatives together, you just total up all the negatives and put a negative sign on it. So 18 and 5 is 23, but they're all negative, so it's negative 23, right? And the last one, if you set x equal to 0, that's how you'd write it. So you're going to write your equation down. You can do what I'm doing if you like. You can put a parentheses for your x and just stick your 0 in there for your x. 0 minus 5 is negative 5.